In this video, we're going to talk more about moving load analysis and some of the results that we can get out of it. So the moving loads we saw in the last example, we just had a single lane of moving loads, but it's possible to have multiple lanes and even different speeds. You can define different increments and so on, different directions. As we briefly alluded to in that last video, we can also combine moving loads with static load cases through the analysis dialog. It's not done through the regular load combination dialog. And something we haven't seen yet, but we'll look at in the next example, is generating influence line diagrams. And that can be done if your moving load analysis wheel load pattern has just a single axle load. And that's what we're actually going to do right now. We're going to look at generating influence line diagrams for the same model that we used in the last exercise. So this is the model that we're referring to. We have two sets of members underneath each long side of this, this model. If I click on the loads window, I can return to this moving load tool dialog. So within this moving load tool, I can actually add another wheel load to my model. You may remember I have members 1 through 8 already loaded with this wheel load pattern, but members 9 through 16 don't have any loads. So if I wanted to add a new wheel load pattern, I could simply do that by pressing the Add button when I have all this information selected that I want to use. I'm just going to copy the loads that I have from the previous load definition and use that on another set of members. So I'll press the Add button, and it's going to copy all this information. The only difference now is that it's changing the lane number to lane number 2. Now I'm going to change the member number from 1 to 8 to 9 to 16. And that's just the other set of members on the other side of the model. We could also change the direction, the orientation, and so on. It doesn't have to be in the vertical direction. We could do lateral loads as well if we had some sort of crane behavior, for example, that might have some lateral induced moving loads. I can change my increment to 0.4 meters to make this run a little faster than the other one. And I just click Update. I'll press OK. And now I'm going to go ahead and run the same analysis again. Run a linear static moving load analysis. And we can see here it's generating all the different load cases again for each wheel load increment. But this time, rather than what we had before where we just had the one side of the model loaded, we're having loads on both sides now. And I can look at the case number 1 here. And maybe I'll just angle it a little bit better so we can see both wheel loads. Make it a little bit easier to see, and I'm just going to increment this over. And it may be hard to tell at first, but the one on the left is moving twice as fast as the other one. You can see here that's kind of getting away from it now. Might be easier to visualize within SView. If we go to Run SView, we'll be able to see the influence of one of those wheel loads moving faster than the other. I'm going to change it to contour view again, and I'm going to generate the contours. And just from this default view here, I can click play the animation. And we can start to see here that it's bending over to this one side more and for quicker than it is on the other side. I explained that very well. You can see it maybe more from this angle. This is a slower wheel load pattern, so it's taking longer to get off of the bridge. Now if we wanted to combine this moving load case with a static load case, this would have to be done in the analysis windows we talked about. So that would be done, let's say that we had a self-weight load case and maybe a dead load case and a snow load case. We could create a combination with just those load cases. Then we just press combine with load cases or combinations and select whatever load combination we define. That's fairly self-explanatory. Now I'm going to do things a little bit differently for this next part here. I'm going to actually delete the existing moving load case that I have. So I'll just say load status. I'm going to delete this load case. It's the only one I have in my model currently. And I'm just going to add another load case in its place. I'm going to say new load case, call this unit load. And I'm going to use the moving load tool to do this. Now we're not going to use this wheel load pattern. We can just see if there's any that might work for us. You notice I have this one that's called unit load. And it has, in this situation, a 4.4478 kilonewton wheel load. If I just left click on this chart option here, I can actually look up that particular wheel load too, and I can see what the details are behind this. So it starts at distance of 0 and has this force. And this will work just fine for what I need it to be. I'll press OK. I'll select it from this list of patterns. I'll choose the direction, which I'm going to say is forward, and I'm going to do the orientation of global negative Z. It's going to go from member 1 to member 8. And the increment that I'm going to use here is 0.2 meters, just like we have before. I'll click Add to add it to my model. So it's going from member 1 to 8 with this increment. Press OK. And now I can go ahead and run the analysis. So I'll click Analyze. Run a linear static moving load analysis. Now this just has one wheel load pattern, so it shouldn't take as long because it doesn't have those trailing wheel load patterns to extend the analysis. And I'm just going to look at this parent load case for the wheel load patterns. And I'll go back to the default view. The parent load case is the top one with the name of my load case. Every subsequent load case that's generated from that I refer to as a child load case. And that all refers back to this unit load that I defined. I'm then going to use the influence line diagrams tool. Left click on this tool, and then I can specify which result I'm interested in viewing. So maybe I'm interested in viewing the Y moment of a specific member on my influence line. I can then left click on the member, and I can see what would happen to all these results based on that influence line diagram location. So I'm just left clicking at a specific point along this member, specified the member and the distance, and I'm getting the Y moment influence line. I could switch this to perhaps a Z shear. I would just have to update this accordingly, and I would get the new diagram out of that. So the one thing to keep in mind with influence lines is that they do require that you use just a single axial load in your load case to achieve this.